A hollow sphere is like a ball, plastic ball, where inside it is equal to empty. So this is a body. Let us assume its mass is equal to m and its radius equal to r. And as it is rightly said in the earlier cases also, we need to calculate the moment of inertia of a basic axis, any one basic axis, using the perpendicular axis theorem or a parallel axis theorem. That's the second part. But in the first part, we need to calculate it about a given axis using a concept of integration. Therefore, here we can say that assume that this body is this hollow sphere is rolling over a floor about a diameter. This is nothing but the diameter of that. We need to calculate the moment of inertia, assuming its mass equal to m, radius is equal to r, using an integrational phenomena, and it can be mathematically proved that its moment of inertia equal to 2 by 3 mr square. Suppose the ring is the same, the hollow sphere is the same, but if started rolling not about the center but about a tangential diameter, tangential axis which is parallel to that of the diameter. So this axis about the diameter is also passed into the center of the gravity of the body or the center of the mass of the body. It can be treated like 2 by 3 mr square. Now I want to calculate the moment of inertia about a parallel axis, and it is very clear that distance between them is nothing but equal to the radius of that hollow sphere. So I can use a parallel axis theorem to identify the moment of inertia I as Ig plus mr square. Ig value is determined basing on the concept of integration as 2 by 3 mr square, and mr square is nothing but equal to 5 by 3 mr square. And anyway, we need to understand one point, that there is no rule that we have to calculate the moment of inertia always about a given axis. Say for example, just for an example, if I am having the same hollow sphere and the axis that I am rotating is, say for example, from the diameter, so is at a distance of, say for example, r by 2. This is nothing but I about the diameter. I want to calculate I. That can be done using the parallel axis theorem, because these two axes are simply parallel to each other. We can write I as I about the diameter plus m. The perpendicular distance between the two parallel axes is nothing but r by 2 whole square, x square, where x is the distance between the two parallel axes. I about the diameter, as it is rightly said earlier, 2 by 3 mr square plus mr square by 4. So I can take mr square as common. So the value is going to be 2 by 3 plus 1 by 4. So it could be like mr square of 12 8 plus 3, that's value is nothing but 11 by 12 mr square. Like this, whenever the body changes, moment of inertia of the body changes, and the simplest way to calculate the moment of inertia without going to the integrational phenomena is using parallel axis theorem and perpendicular axis theorem.